Hi, I'm Larry Richards from the University of Virginia. I teach in the Department of Mechanical and Aerospace Engineering, and for the last 12 years I've been working on K-12 engineering education outreach. Among other things, we've developed engineering teaching kits. These are designed to bring engineering concepts and the engineering design process into the middle school or high school classroom. Today we're going to talk about a particular ETK that has to do with solar cars. The students design and build a solar car, and in the process they learn about the engineering design process. So in this exercise, students learn about how solar cells work. They do measurements on solar cells to find out which solar cell is best under a variety of light sources. They then go on and learn about motors. They get several motors to test with the idea that they want to select the motor that will pull the most weight. They learn about friction and tire materials, and then they have to build a solar car. The purpose of the solar car is to pull a cart on which we have weights. The students design the cars that work best while working in groups. They use their knowledge to decide upon the best motor, the best light source, the best wheels, and then they design their car. Since this is a design-based activity, we ask the teacher to be there as a coach and a help, but not to get too intrusive. That is, we want the groups to develop their car on their own. Each team is provided with a box of basic building materials. This box includes motors, solar cells, it includes a battery pack, Lego wheels, Lego gears and axles, and all sorts of building materials. We also include fishing line and alligator clips, and the students have access to all the duct tape and other things they need. Each group will need access to multiple sources of light, that is to say, the sunlight, an incandescent light, which is usually a 150-watt light bulb, and then a halogen lamp. All groups have access in addition to additional Legos, gears, wheels, and duct tape. Fishing weights are also provided so that each team can use these to determine which car pulls the most weight. Finally, the students build the cars. While they're doing this, the teacher should be present and give help when needed, but not too intrusive. That is to say, this is the student team that's designing the car, and minimal help from the teacher, but some guidance is in order. The students build their first design. After that, they test it and hopefully see ways to improve it as a result of this first test. This gives them an appreciation for the engineering design process, which includes coming up with the idea, designing it, building it, and then rebuilding until they get it as good as they want it. And part of this is driven by the competition from the other cars that they see and how they perform. So in the end, the students gain an understanding of the engineering design process, and the final result for each team is how much weight that team can pull. And then of course we put the teams in competition with each other to try to decide which team pulls the most weight. This summer we had a blast at the University of Virginia. Blast was an intense summer experience for high school students focused on science and engineering. The first two sessions of Blast involved 160 students and 13 teachers. Blast was a partnership between the Commonwealth of Virginia and the Virginia Space Grant Consortium. The idea and funding for Blast came from Delegate Joe T. May, an engineer, inventor, and businessman. Next year there will be additional sessions of Blast at Virginia Tech and the University of Virginia. For more information, visit the Blast site or the Virginia Space Grant Consortium site at the links shown here. Margot Ferraletto filmed, edited, and produced these videos, and we thank her for all of her efforts and for serving as an intern at UVA this summer.